This is the Data Center Frontier Show, where we tell the story of the data center industry and its future. Our show is hosted by Rich Miller, the editor of Data Center Frontier. This podcast is brought to you by T5 Data Centers. And now here's Rich with our show.
My first encounter with a robot in a data center came in 2015. I was touring the massive Facebook data center campus in North Carolina, and I got an early look at a new storage system for rarely accessed data, known as cold storage. I walked into a large, mostly dark data hall to a row of racks housing this new cold storage system, which used high-capacity Blu-ray discs to store old photos and status updates. They were housed in these large rack-based storage units that can hold thousands of Blu-ray discs. And each of these racks included a robot retrieval system, which was housed in the bottom of the rack. When data was requested, this robotic arm springs into action. It runs along these tracks on either side of the rack, fetches a Blu-ray disc, pops it in a drive, pulls data off the disc, and then writes it to a live server. I'm Rich Miller, the editor of Data Center Frontier, and our topic today is robots in the data center. The idea of using robots to automate data center operations has been the object of years of science experiments and proof of concepts in the data center industry. But last week, a data center startup called TMG Core demonstrated a robotic system that can replace servers housed within an immersion cooling tank. This ability to swap out servers creates new possibilities in the industry's long-running effort to create a lights-out, unmanned data center. Which raises a question. Are we on the verge of a new frontier in data center automation? Today, we'll talk about the history of robotics in the data center, look at some implementations, and discuss how they may help shape the data centers of the future. First, why robots? There are three important reasons for the fascination with the use of robots in the data center industry. The first is the industry's long tradition of continuous improvement in automation and greater efficiency, which has really intensified in recent years as teams of system admins have had to manage a larger and larger volume of servers with the rapid growth of the internet. Secondly, automation has also been advanced as a way to improve uptime by detecting potential problems and intervening to address them before they result in failures and downtime. The third reason is that robotics has been discussed as a potential method to address the looming workforce shortage facing the data center. Many folks believe we are likely to see shortages of skilled data center staff as experienced employees reach retirement age. Now, it is hard to talk about AI and robots without first noting the public anxiety about the technology becoming self-aware or ushering in our new robotic overlords. It's not an accident that Americans wonder if artificial intelligence will turn the tables on its creators and subjugate humanity. It's a reflex drilled home by decades of Hollywood blockbusters like the Terminator series or the Matrix series or Alien or Westworld, or Avengers Age of Ultron or Tron. You start to get the picture. So it's important to note that when we talk about robots in the data center, we mean industrial robots that really bear little resemblance to the humanoid Terminators that we see in the Arnold Schwarzenegger movies, and are much closer to the large mechanical arms that you might see on factory floors and assembly lines. Folks have been talking about a lights-out data center for a long time. Back in 2006, HP announced plans to move to a lights-out model, which frankly I've never seen implemented at any kind of scale. Maybe it's a secret. About 5 years later, in 2011, AOL said that it had created a small, completely automated, unstaffed data center. More recently, we've seen a more ambitious rollout of lights-out data centers from EdgeConneX, which has built about 25 edge data centers around the country that are operated largely unmanned through the use of extensive monitoring and a operating system that's been optimized to keep an eye on things and deploy warm hands if they are needed. In 2013, this topic came up when I was talking with Bill Clayman, who has written for both Data Center Frontier and Data Center Knowledge, where I was the editor at the time. Now, Bill loves all kinds of new technology and was fascinated with the potential for robots to operate in data center environments. So he did a series of stories about the rapidly advancing capabilities of some of the industrial robots created by companies like DevLinks or Japan's Fanuc. This was one of the first meaningful discussions of how factory robots might be adapted for data center use, including equipment replacement, and as well as the major obstacles that present challenges to this idea. So, what does the road to data center robots look like? We'll explore that after this short break. I wanted to take a moment to give a special shout out to T5 Data Centers, which is sponsoring today's episode of the Data Center Frontier Show. T5 is a leading data center owner and operator that has built more than 4 million square feet of data center space and currently operates over 550 megawatts of mission-critical infrastructure. T5's purpose-built design, superior facilities management, and construction services platform have been perfected through decades of experience delivering world-class data centers to many of the world's best companies, creating the foundation of T5's forever on performance. T5 is committed to recruiting and retaining the best data center talent in the industry, with more than 60% of its operations team having served in the military and achieving a retention rate of more than 88%. If your company demands forever on, demand T5. Visit www.t5datacenters.com to learn more. Robotics has been used for many years in different types of data center operations. That includes the cold storage operations for older data that I discussed earlier. But even before the Facebook Blu-ray system, tape storage archives were seen at Google and high-performance computing data centers, using robotic arms to locate and retrieve backup storage tapes. In 2013, IBM got some attention when it adapted models of the iRobot Roomba vacuum to monitor temperatures in its data centers. IBM customized a Roomba that will wander around the data center with sensors and a webcam attached, measuring the temperature and humidity. IBM also created maps of the distribution and the heat, and the robots were equipped to scan RFID tags and manage inventory. At the time, IBM said that it was using these in 9 data centers, but I haven't seen any subsequent accounts to suggest that this was more broadly implemented. In 2018, Google's Joe Cava disclosed that the company was using industrial robots to smash some of the used hard drives that were being decommissioned. When a disk can't be verified as being fully and properly wiped, they shred the hard drives, and they found that the robots could be really useful in this process, particularly when they were doing a lot of swap outs for equipment refreshes. But one of the most interesting applications of robotics has been in interconnection. In Frankfurt, the interconnection specialist DCX created a robotic system which it named Patchy McPatchbot, a suitably internet-friendly name, which has automated the provisioning and upgrading of its network. So Patchy is mounted on an optical distribution frame instead of a standard rack and has a robotic arm that can plug and unplug connectors as well as manage cables. They have a pretty cool video of Patchy McPatchbot in action, which we will share in the show notes and you should totally check out. There's also a company called Wave to Wave, which has a robotic optical fiber switch, which also uses robotic arms to manage cross connections. The switch, known as Roam, is 19 inches wide and thus can fit into a standard rack. Wave2Wave has worked with NTT on automating fiber deployments in Japan. And this robot knows the position of all the ports within the chassis and can manage cables and the slack in the cables with pretty surprising precision. So how do we make the transition to robot server management? Interestingly, the front lines of this effort can be found in the field of immersion cooling, where the servers are dunked into a tank of liquid coolant. I had never really thought that much about how immersion could lead to the creation of unmanned data centers using AI and robots. But then I spoke with Scott Noteboom, who many of you may know from his work at Yahoo, where he designed an extremely efficient data center known as the Compute Coop. It was a data center that borrowed design concepts from the thermal management of a chicken coop. Scott likes looking at innovations in other industries and bringing them into the data center. And he's been a thought leader in applying AI to managing data infrastructure. Now, he just joined immersion specialist Submer as its CTO. And Scott has a vision for a future filled with autonomous data centers, which could look very different from the data halls that you see today. Noteboom believes that robots and software can create a data center environment completely optimized for machines, with no humans involved at all. He helped develop AI agents that can monitor the sound of generators, for example. So the sound of generators is generally pretty consistent, and the audio can listen for any anomalies that would require attention. And then the AI agents report this back to the staff. Scott points to the highly automated operations of warehouses as an example of what data centers might be able to accomplish. If you think about it, there's a certain amount of similarities. Like warehouses, data centers have a well-organized structure. They've got a lot of automation and a floor plan that's laid out to be as efficient as possible. Now that robots can smash hard drives and swap out storage media and even network connections, the next frontier is servers. How will that work? We'll talk about this when we come back in just a moment. At Data Center Frontier, we've been doing a series of market reports looking at the major markets in the data center industry. We take each geographic region and we talk about supply and demand and internal market dynamics. Our latest market report is about Greater Chicago, which is home to more than 3.4 million square feet of commissioned data center space. After a couple of years of solid but maybe unspectacular leasing, we're starting to see more interest in the Greater Chicago market, largely due to the recent passage of a new tax incentive package from the Illinois State Legislature. If you want to learn what's going on in the Chicago market, including new entrants, supply and demand, and all of the service providers that are active in the market, go to datacenterfrontier.com, and we will have a link on the front page of the site to the Greater Chicago Data Center Market Report. It's also available in our white paper library, where it's downloadable for free, and we will have a link to the report directly in our show notes, which you can check out on our website at datacenterfrontier.com/podcast. Welcome back to our discussion of robots and data centers. Shortly after I spoke to Scott Noteboom, I had a briefing with TMG Core, which has turned that vision for robotic data centers into a working automation platform it called Otto, OTTO, which is demonstrated on the expo floor at the SC19 conference, which was held last week in Denver. John David Enright, who is the CEO of TMG Core, shared the details of the company's technology, which uses two-phase immersion cooling, in which the servers are immersed in a coolant fluid, typically Novec from 3M, which has a low boiling point, and thus it boils off as the chips generate heat, removing the heat as it changes from liquid to vapor. Then a condenser is typically used to cool the vapor and turn it back into liquid for returning to the tank. Enright and his team designed these micro-modular data centers to house the immersion tanks. and wanted to create a robotic system so the servers could be swapped out without human intervention. So TMG Core worked with Olympus Controls, which creates robotic systems for factory automation, and adapted the technology for physical server management. The robotic arm was customized so it can latch onto a server, pick it up, lift it out of the immersion tank, and place it into an enclosure located right next to the tank that houses backup servers and has open slots where the robotic arm can place the failed server. The system then can grab one of the backup servers out of an adjacent slot, lift it up and into the tank, and pop it into this plug-and-play backplane that is at the bottom of the tank that provides the power and fiber connections for the servers. TMG Core has just demonstrated the platform for the first time, so it really remains to be seen how the market will embrace the technology. But it does pose a pretty interesting question about the future of robotics in the data center. First, it's really important to be clear that there are always going to be humans involved in data center management, in most data centers anyway. But in the near future, we'll begin to see a disconnect between the enormous volume of servers and storage that must be managed and the volume of skilled workers available to manage that data. Robotics is emerging as part of the toolkit the data center industry must use, really, as it seeks to accelerate the automation of cloud computing. In the unmanned data centers operated by EdgeConneX, the automation is driven by really sophisticated software and management tools, along with sensors that allow the system to collect data. Preparing an entire facility for robot server swapping is a larger challenge. I don't think we're close to that right now. But what data centers have going for them is that they are standardized, which creates an opportunity because robots are good at repeatable tasks with an unchanging canvas or environment. They can work with great precision in these type of environments. That's why robotic management is likely to be seen first at hyperscale operators who can control their entire environment and who can begin to design their servers, racks, and data halls with robotic management in mind. Amazon's extensive use of robotics in its warehouses and distribution centers provides a glimpse of what type of optimization is possible when you design the entire building and operation around the capabilities of robots. Unmanned or lightly staffed environments also allow efficiency gains by letting the facility operate at higher temperatures and humidity, which has always been a key focus for hyperscale players like Google and Microsoft. In hyperscale data centers, for example, you could design a rail-based system, much like the one created by TMG Core, with racks positioned adjacent to the rails. This might work best with the racks positioned horizontally, as they are with an immersion tank, rather than the traditional vertically placed racks. An interesting wrinkle is that a robot-managed facility creates interesting possibilities for expanding vertically, stacking rows of data containers above one another. Human management and access, of course, will always be required for backup, so some sort of system of platforms or gangways would also need to be included. As we've noted on Data Center Frontier, many data center developers are already building 3- and 4-story buildings. Or in the case of Facebook, an 11-story facility. They have this massive 1.8 million square foot building they're creating in Singapore, where real estate is at a premium. So this all tracks with some of the existing industry trends. There's no question that the concept would pose some interesting challenges around cabling and design. Co-location and multi-tenant data centers, of course, are a very different story. These facilities have to be flexible to accommodate whatever diverse type of equipment their customers want to place in the cages and cabinets. But one area where the lights-out data center will become a priority is edge computing, which could soon see hundreds and perhaps even thousands of small data centers in distributed locations. As a practical matter, the majority of edge data modules and enclosures will need to operate without a human on site. That's the only way to make the economics work. I believe that we are in the early days of robotics in the data center. While there have been some interesting early projects that we've talked about today, the greatest potential is yet to come. It will be a topic to watch as we continue to tell the story of the data center industry, one podcast at a time. Thanks for listening. Today's podcast was brought to you by T5 Data Centers. Contact T5 today and begin a conversation about how T5 can accommodate your custom-built data center facility. Learn more at www.t5datacenters.com. T5, forever on.
Thanks for listening to the Data Center Frontier Show. You can find the show notes for this episode at datacenterfrontier.com/podcast, including links to the resources Rich has mentioned. Be sure to subscribe to the Data Center Frontier Show at Apple, iTunes, Spotify, or where you find your podcasts. If you enjoyed this show, please tell your friends or share about it on your social channels. You can always find us on the web at datacenterfrontier.com and follow us on Twitter, Facebook, and LinkedIn. Until next time.